Greetings from EPG Pathshala. In this module we are going to discuss about enumerating the content and functionality. The title suggests that when we are browsing a web, we are browsing many websites. Now those websites may follow a directory structure where you start with a home page and then you go to the certain links and get the content. So enumerating content means try to browse through all the possible links and find out what all contents are there. And functionality means what the website provides, what functionality. So what an adversary will do, he will try to find out the application's functionality, and based on that it will try to manipulate and attack the website. So we will start our point by saying exactly what does the enumeration mean, enumeration of content and functionality mean. If attacker wants to attack an application, the first and prime thing is he has to gather the application's details by examining some key information, and he has to get a better understanding of how the application is organized and what it is doing. So the attacker or the adversary would start by enumerating the application's content and functionality so that have a better understanding of what the application does and how it behaves. The functionalities are usually easy to identify, but there are certain hidden functionalities and it requires a degree of guesswork and a little bit of luck to discover. After a catalog of applications functionality has been gathered, the main task is to examine deeply every aspect of its behavior, then core security mechanism it employs, and the technologies being employed on both the client and the server side. This would enable the adversary or attacker to identify the key attack surface that the application is exposed to, and then finding out the interesting areas where the adversary should target the subsequent probing to find exploitable vulnerabilities. This exercise leads an attacker to uncover vulnerabilities. If I talk about typical application, web application, the majority of the content and functionality are identified via manual browsing. If I talk about a typical web application, the majority of the functionalities are identified by manual browsing. So walk through the application starting from the main initial page, follow each link, navigate through all multi-stage functionality, and if the application contains site map, then it would be a big starting point for enumerating the content. First is web spidering, in which various tools can perform automated spidering of websites. These tools work by requesting a web page, parsing it for links to other contents, requesting these links, and continuing recursively until no more unbrowsed content is found. User-directed spidering, in that the user walks through the application in the normal way using a standard browser. User is trying to navigate through all the application's functionality. The resulting traffic is passed through a tool combining an intercepting proxy and spider which monitors all requests and responses. The tool builds a map of the application incorporating all the URLs visited by the browser, parses all the application's responses in the same way the normal application-aware spider, and updates the site map with the content and functionality it discovers. This approach has many advantages compared to the basic spidering approach. where the application uses unusual or complex mechanism for navigation, the user can follow this using a browser in normal way. Any functions and content accessed by user are processed by the proxy spider tool. The user controls all the data submitted to application and can ensure that the data validation requirements are met. The user can log in the application in the usual way and ensure that authenticated session remain active throughout the mapping process. If any of the action performs results in termination of a session, the user can log in again and continue browsing. Any dangerous functionality such as deleting the user is fully enumerated and incorporated into proxy sitemap, because links to it will be parsed out of the application's response, but the user can use discretion in deciding which functions to actually request or carry out. We have seen user directed spidering, and next is discovering the hidden content. Sometimes applications contain content and functionality that is not directly linked to or reachable from the main visible content. The common example is the functionality that has been implemented for testing and debugging purposes, and those are never been removed. One more example that arises when the application presents different functionality to different categories of user. How many categories of users are there? Anonymous user, authenticated regular users, and administrators. So usually each one has a different access of different functionality. Users at one privilege level who perform exhaustive spidering of the application may miss out the functionality that is visible to users at other levels. The attacker who discovers the functionality may exploit it to elevate his or her privileges within the application. Now we will look at the case where automated web spidering is not useful. If backup copies are there of the live files, in that case dynamic pages and their file extensions may have changed to one that is not mapped as executable. So it enables one to review the page source for vulnerabilities that can then be exploited on the live page. Backup archives, those are stored that can contain a full snapshot of the files outside the web root or maybe within the web root directory. It enables attacker to easily identify all content and functionality within the application. New functionality that has been deployed to the server for testing but not yet linked from the main application. So certain web pages doing certain functionalities are ready, but they are not yet linked with the main page. Default application functionality in an off-the-shelf application that has been superficially hidden from the user, but it is present in the server. There are old versions of files that have not been removed from the server. In case of dynamic pages, this may contain vulnerabilities that have been fixed in the current version, but they can still be exploited in the old version. There are certain configuration and include files, those contain sensitive data. To give you example of sensitive data, they may contain database credentials. Source file from which the live application's functionality has been compiled. Comments in source code that in extreme cases may contain information such as usernames or passwords. Those comments are more likely to provide information about the state of the application. There are key phrases such as test this function or something similar are strong indicators of where to start hunting for vulnerabilities. There are log files. Log files may contain sensitive information such as valid usernames, session tokens, URLs visited, and action performed. If one wants to effectively discover the hidden content, it requires combination of automated and manual technique. And it is often relying on the luck whether you will be able to find out the hidden content or not after all the efforts. There are brute force techniques. Brute force technique says you already have adversary attacker has already gone through the structure of the directory where the website is loaded. Structure is found out, but there are still more directories and subdirectories that one would need to browse through or go through. Then they need additional pages to be found out for the application, and that is where brute force technique can be applied, trying to discover more directories and subdirectories for additional pages. The next is use of public information. The application may contain content and functionality that those are not presently linked from the main content, but that have been linked in the past. So in this situation, it is likely that various historical repositories will still contain references to the hidden content. There are two main publicly available resources. One is the search engine and other is a web archives. To name search engines, there are Google, Yahoo, Microsoft. These maintain a fine-grained index of all content that are their powerful spiders have discovered. So all search engines have a web spiders which find out the content. So the content has been indexed on all those search engines, and they have also cached the copies of much of this content which are there even after the original content has been removed. There are something called web archives such as Wayback Machine located at www.archive.org. These archives maintain a historical record of a large number of websites. In many cases, they allow users to browse a fully replicated snapshot of a given site as it existed at various dates going back to several years. There are another source of public source of useful information about the target application is the posts. Those posts which developers and others have made to internet forums. On internet, there are many forums in which software designers and programmers ask and answer technical questions. Items posted to these forums contain information about an application that is of direct benefit to an attacker, including the technologies in use, the functionality implemented, problems encountered during development, known security bugs, configuration, log files submitted to assist in troubleshooting, and even a few parts of the source code. Next is, in case of enumerating the content and functionality, next is leveraging the web server. It says vulnerabilities may exist at the web server layer that enable one to discover the content and functionality that are not linked within the web applications itself. There are bugs within web server software that can allow an attacker to list the contents of directories or obtain the raw source for dynamic server executable pages. If there is a bug that allows an attacker to list the contents of directories or obtain the raw source of dynamic server executable pages, then they may exploit it to directly obtain a listing of all pages and other resources within the application. Many application servers, those are shipped with default content, they may help one to attack. For example, there are sample and diagnostic scripts. Those scripts may have vulnerabilities or functionality that may be exposed or they may be tried upon for a malicious purpose. There are many web applications incorporate common third-party tools for standard functionalities. For example, shopping cart. So there are certain third-party tools that implement the shopping cart functionality, or discussion forums, or content management system. They are usually installed at a fixed location relative to the web root or the application's starting directory. There are certain automated tools that those lend themselves naturally to this type of task, and many of them issue requests from a large database of the known default web server content, third-party application components, and common directory names. These tools means automated tools do not rigorously test for any hidden custom functionality. They are useful in discovering other resources those are not linked within the application and that may be of interest in formulating an attack. Next, we will talk about application pages versus functional path. This says if you are provided with different number of different application pages and you are provided with the function that page is performing, so which one is useful to attack? Up till now, whatever enumeration techniques we have discussed, they are implicitly driven by one particular picture of how web application content may be conceptualized and cataloged. So usually World Wide Web started with this kind of structure in which web servers function as repositories of static information retrieved using URL. In turn, they are the file names. But to publish some web content, an author may generate group of HTML files and copy those HTML files to the relevant directory. When the user followed hyperlinks, they could navigate the set of files created by authors and requesting each file by its name within the directory tree residing on the server. But if application is using the REST style URL, parts of the URL file path contain strings that in fact has a function as parameter values. REST suggests that within the URL which you specify the function as well. Suppose I want to browse through the department computer, my URL will contain computer, and if I want to go through the information technology department, my URL would contain information technology. So I would land up in the exact page of that function. In this situation, by mapping URLs, a spider maps both the application functions and list of known parameter values to those functions. For example, there is an application that is accessed using only request of the form post bank.jsp http 1.1. You can check the host, content length, who is the servlet. The servlet used is transfer funds and method is equal to confirm transfer, and from account is equal to 10372918 and to account is 3910852 and amount is 291.23 and submit OK. So every request is made to a single URL. The parameters of the request are used to tell the application what function to tell by naming the Java servlet and method invoke. So in the example, the servlet was transfer fund. So it is clear that this servlet is transferring the fund, and by looking at the parameter, additional informations are got from which account to which account. In the picture based on application pages, the application appears to have only a single function, and a URL based map does not elucidate the functionality. But if an application is mapped with a functional path, one can obtain much more information and a catalog of functions the application is doing. In applications where functions are identified using a request parameter rather than the URL, this has implications for the enumeration of application content. Next is discovering the hidden parameters. We have seen a situation where an application uses request parameters to specify which function should be performed. There is a slight variation in which other parameters are used to control the application's logic. in a very significant way. Working with an application, it may behave differently if the parameter debug is set to true. And if debug is equal to true is added to the URL, it may start in the debugging mode. And it may turn off certain input validation. It may allow user to bypass certain access controls. It may display verbose debug information in its response. In many cases, the fact that the application handles this parameter cannot be directly inferred from any of its contents. Means if debug is equal to false in the URLs, it publishes as a hyperlinks. The effect of the parameter can only be detected by guessing a range of values until the correct one is submitted. So this is how we can discover the hidden parameters. To summarize this module, we have checked that how to enumerate the content and functionalities. We have seen that the traditional World Wide Web uses the URLs to call any page. They may not specify the functionality the page is performing, but if REST style URLs are used, then one can derive what functionality this page is performing.